Alright, we're going to go over some problems from lesson 84. I decided to do a video for this just so I can explain it better. These are Nate's problems, I think, but other people can benefit from them. Number 5 says Leona found 3 consecutive integers such as the product of 5 and the sum of the first 2 was 7 greater than the opposite of the third. What were the integers? Tough question. Alright, let's see if we can do it here. So I'm going to look here. We know it's consecutive integer problems. It doesn't say even or odd integers. So we're just going to have x is the first one. X plus 1 is the second. And x plus 2 is the third. If it would have said odd or even, you would have put plus 2, plus 4. It's never plus 1, plus 3. It's always even. It's either plus 2, plus 4, or plus 6. So 3 consecutive integers, the product of 5 and the sum of the first 2. So it's the product of 5 and the sum of the first 2. So product means multiplication. So I'm going to multiply 5 times the sum of the first 2. Well, the first one's x, the second one is 1. So I just keep rereading the sentence and write down the equation. Was 7 greater? Okay, so was is the same as is, it's just the past tense. 7 greater, so you should always put that if it's 7 less or 7 greater, you should put that at the end. Is 7 greater than the opposite of the third? Here's the very, very tricky part of it. It's the opposite of the third. So opposite means you're going to negate the whole entire thing. If you just said minus x right here and then plus 2, then you probably got the problem wrong. So it's 5, the product of 5 and the sum of the first 2 was equal to 7 greater than the opposite of the third. So once we get the equation down, it should be easy. So we'll just add inside of the parentheses. So we get 2x plus 1 equals minus x minus 2 plus 7. 10x plus 5 equals minus x plus 5. We're going to get all the x's on one side, all the numbers on the other side. Gee, I hope this works. So we get 11x. I'm going to add x to both sides, equals 0. And what I got is x equals 0. I'm going to just check and make sure that's right. 84, number 5. Yes, that's right. I'm always a little scared when I get 0. So that's our first number. So we take our x, that says x equals 0, so x is 0. If I add 1, we get 1. And if we add 2 to 0, we get 2. So these are our consecutive integers. That 5 times the sum of the first 2, so 5 times 0 plus 1 is 7 greater than the opposite of the third. That would be the opposite of that one. So we're going to get 5 equals 5, and so we got it correct. Let's move on here to number 7. 7 says, indicate which of the following diagrams designates a function. Remember, function is a one-on-one correspondence. Out of the x value, you can only get one y value. So if we're going to look at A, every one maps on to the other one. So we have 1 goes to 1, 2 goes to 3, and 3 goes to 2. That's a one-on-one correspondence. Let me see if I can find the exact definition for a function here. Function. Let's see, that's a relation. Here we go. A function is a mapping of or correspondence as shown below. So it doesn't really give you the definition of a function. Let's just look at another one until we find an example of something that's not a function. That's a function. The next one is 1 to m to 1. This one goes to 1. This one goes to 1. This one doesn't go to anything. This one's a function. This is not a function. Because in a function, every x value has to have its own unique y value. So that's not a function. Let's do one more. 1, 2. 3, 4, 5. 1 goes to both 3 and 4, and 2 goes to 5. This one's not a function because we have two values that come out of the x value. So this is not a function, not a function. Here we have, you could have 1 go into 4 and 2 go into 4, but you can't have two different numbers coming out of 1. This one's actually called a relation. It's not a function, but it's a relation because everybody's matched up. This one is not a function and it's not a relation. And then the final one is 5, 6, 7, and 1. 5 comes out and goes to 1, 6 comes out and goes to 1, and 7 comes out and goes to 1. This one is a function. As long as there's not 2 coming out of the x values, it's a function. So this one is not a function because we have 2 coming out of the x one. This one's not a function because everyone needs to be mapped to someone. So this one is a function, this one's a function, this is not a function, this is not a function, but it is a relation. This isn't a relation because this guy here isn't matched up to somebody. So hopefully that clarifies that one. Let me move to 11 to 13 now. 11. Let's see what that one is. Okay, this one wants you to find the domain and range of the graph figure. Now I don't have the graph here. Maybe I can put a graph in for you. Now let's see if I can do that. Alright, so I'm going to try to fill in the graph here. They have something, they have a point on -4, 1, 1, 2, 3, 4, 1. And they have a point on 4, 1. 1, 2, 3, 4, 1. And then in between they have some scribble scrabble stuff. And it looks like, well, it's really hard for me to draw this, but it looks like it goes up to, on the y-axis it goes up to 2 here, and the lowest point it looks like it goes down into is -1. Like about here and about here. That's just a really quick making up of this. So it kind of looks like this. It goes down, up, and then it comes down here, and then up, and then it does a little jiggle joggle, and then it comes down here, and it comes back up. She did that in a better color. So you're going to find, for this one they want you to find the range and domain. Now here we have, this is our y-axis, this is our x-axis. The distance from where it starts on the y-axis to where it ends on the y-axis, all these values, is your domain. This is your y value, is your range. This distance here from where it starts on the x-axis until where it ends on the x-axis, that is your x values, which equals your domain. Remember, d goes with x and y goes with r. X comes before y and d comes before r. I don't know if that helps or not. So when we're going to write this, out. The book writes it, every book seems to write how to do the domain and range differently. So this one says the domain is equal to, and it'll say, this is how they say it, x is an element of the real numbers such that, and you'll notice x goes between -4 right here to 4. So such that x, well, let's just do it this way. -4 is less than or equal to x is less than or equal to 4. So just remember, your domain is your x value. So it goes from, this would be, goes from -4 to +4. So your domain has to be from -4 to +4. And then we'll deal with our range. Our range is y is an element of the real numbers. I don't care if you put this. Such that, this is what I'm really looking for right here. And you notice the range goes between 1, 2 and -1. So we would have our ranges between 2 is less than or equal to y is less than or equal to -1. Notice these dots are filled in. That's why we have the and equal to sign. So that's your domain and range. That was kind of challenging. We'll get into more of these in Algebra 2 and pre-calculus. Okay, the last problem is number 13. Solved by elimination. We can't seem to get over this kind of problem. 4x plus 3y equals -14. 3x plus 2y equals -10. This elimination problem is kind of hard because there's not an obvious thing that you multiply one equation by to eliminate a variable. So, if you can't see anything you can multiply this one by to eliminate it, you have to multiply both of them by something. So I'm just going to pick these numbers are the smallest. If I multiply this one by -2 and this one by a +3, I'll get -6y and +6y. This is just one way to do it. Another way, you could have taken the 4 by a 3 and the 3 by a -4. Now just remember, you have to multiply every term in the equation by whatever number you choose. So what that's going to give us, I'm just going to write it over here. I'm going to get -8x minus 6y equals +28. And then the bottom one, I'm going to get 9x, more like a 4, 9x plus 6y equals -30. So in this case, I had to multiply both of these equations by something in order to get somebody that will eliminate. So we're going to get x equals -2. They made that easy. Let me just make sure that's the right answer. 13. No, I got the wrong answer. Guess I'm going to have to look at this again. Oh, you know what? I'm looking at 14. I did problem 14. Darn. Okay. So anyway, that's how you would do 14. Let's do 13 now. 13. Copied the wrong problem. Y equals -2x minus 2. Y equals -4. They want you to do this one by graphing, and I didn't leave enough space to do this by graphing. So hold on 1 minute, and I'll try to make a graph for you. See if I can do that. Having a little bit of trouble here. Now let's come over here. I can't seem to make my rectangle over here black. Okay. I'll just do it on this white surface then. Okay, let's put in a graph. Sorry about this. Okay. We have our graph. This is number 13. We're supposed to graph it. I have to change my color. So we have y equals -2x minus 2 and y equals -4. So we have to graph these. First we'll graph this one, y equals mx plus b. Our m is -2. Our b is -2. So let's graph that. B is -2. Remember the slope, you always have to make it into fraction. So we go down 2 and to the right 1. Those are our 2 points, and we take a line and we connect those points. Hopefully we can. And we'll eventually get this. No, it won't let me do much more than that. Okay. You get the picture right. Okay, and then we have y equals -4. Remember, it's a horizontal. If we flip that up, it's an H. It goes through the y-axis at -4. So we go 1, 2, 3, 4. So it's going to cross through here. And the point where it intersects, that's the answer to the problem. So right here is where it intersects. Right here, and so, whoops, let me do that. So this is the answer to your problem right here. It would be, assuming my line's not too off, it might be off. 1, 2, 3, 4, -4, 1, 2, 1, 2, 3. So according to my graph, it should be, I'm wondering if it's off too much. It probably should intersect more here, but my graph might be off. So the answer to this one is 1, -4. 1, 1, let's see, I might be looking for the wrong one again, 13. 1, -4 isn't even close to what I have. We know y has to be -4. Oh, you know what I did? I put it in the wrong spot. Boy, I'm messing up left and right. Sorry, Nate. This line right here is supposed to be -4. So let's do another line. Let me just do another red line. On -4. I don't want to start the video over. 1, 2, 3, 4. There we go. That's much better. Okay, here's our answer. Right there. So it's 1 and -4. All right, that's it for your 4 problem.